Okay, what is colligative property? Okay, this is a textbook version of definition, which I don't like so much, but let's kind of go into it. Okay, properties that depend upon concentration of the solute molecules or ions, but not upon identity of the solute. Okay, what does that mean? So let's kind of go back a little bit, knowing the definition of solute versus solvent. Okay, so when you have a salt water, okay, how do you make salt water? You pour salt into the water, right? So water is actually solvent, and solute is a salt. Okay, so what does that mean? So that solute is dissolved in solvent. That's basically what the solute and solvent is. Okay. So here, colligative is a means what? Bound together. Okay. So solvent molecule, which is water, is bound with solute molecules such as what? Whatever that dissolves in water, salt, sugar, or whatever stuff it is. This means we can change certain properties of solvent. What was solvent again? Water. By adding some solute, which is what? Like a salt and sugar. Okay. What does that mean? Let's kind of go into another one example of intermolecular forces again. Okay. So now you just have a pure water here. Okay. So from water to water, you have no other bond between what? Between water is what? Hydrogen bond, purely, right? Okay. But now you have a salt. So another example here, have a Na plus Cl minus. Let me actually change that screen setting. There you go. Okay. So now the water is next to these ions. Remember how water is partially charged particles, right? You have a high concentration of oxygen, creating partial negative, partial positive, compared to the salt has a full charge of positive and negative. So just by looking at it, this is a much greater force when it comes to charge-wise compared to partial charges, right? Kind of makes sense, right? So when salt is being dissolved in water, what happens is oxygen side, which is a negative side, stabilizes positive side. So there are a whole bunch of water surrounds that positive. So this is oxygen side, okay? Compared to chlorine is a negative charge, therefore the positive side, which is hydrogen side, is facing toward chlorine. So it's going to form like this around it. So think about it. You have a full charge attracted to the partial charge compared to partial charge attracted to partial charge. Which do you think is going to be stronger? Of course, full charge with the partial charge, right? So let's kind of think about it. When you're thinking about evaporation, you know that we have to break this hydrogen bond off. Okay? When you're in the salt water, not only you are breaking apart with another water, but also with what? We have to break apart the stronger bond between oxygen and the sodium, or hydrogen with chlorine. So you not only have to break apart that hydrogen bond, but you also have to break apart that bond, which you call it ion dipole bond. Okay, that's a little new concept, right? Okay, so ion dipole is actually stronger interactive intermolecular force than hydrogen bond is. Okay, remember when we talk about intermolecular forces, there are stronger forces than hydrogen bond is. This is one of them. Okay, you have a partial charge is attracted to the full charge that creates stronger bond. So this water to come out to be evaporated, it not only has to break apart the hydrogen bond, but also has to break apart the ion dipole bond. Why is this called dipole, not ion hydrogen bond? Remember, when we're looking here, we categorize a hydrogen bond because we have to distinguish from this bond to the one weaker than this one, right? Which we call the dipole. Yet, this is still dipolarity there, right? So we kind of group them as a dipole. That's how we kind of put it as a term-wise, okay? So that dipole force, which is specifically hydrogen bond, has to break along with that. So think just basically this takes a stronger force to come off of it than this to come off of it. Okay? So what happened is by adding salt, what happened was your evaporation for water to evaporate means for the water to boil, it has to be what? Higher than 100 degrees Celsius. Okay? Hope that makes sense in terms of intermolecular forces. Okay? So that affects not only that, it says lowering vapor pressure. Of course, what was the vapor pressure? How much a substance is willing to evaporate. When you are with stronger bond, it will not evaporate as much. So it decreases that vapor pressure. Boiling point elevation, we talked about earlier just now, because you have to break apart from the higher bond, it requires a higher temperature to break apart. Freezing point depression. Okay, I'm going to explain this next time because your time is running out, but I'm going to talk about this because this has to be, especially when it comes to water, this requires some structure explanation to it. And change of osmotic pressure. We're going to talk about this too next time too because osmotic is a little bit different. We haven't really talked about much about these, especially osmotic pressure. You probably, bio class, you probably learned about osmosis. That's what this topic is going to talk about. Okay? Alright, so it looks like our hour has passed. And seems like that's good for now to stop here. If there's any questions, do not hesitate to ask, and we'll see you guys next week.